All right, the purpose of this video is to show another way to do long division. Now, the last time that Miss Kate Owens came to visit the classroom, we looked at some of the tests that the students had taken, and one of the areas that we saw weakness was their ability to do long division correctly. Now, I showed one method already, and my students are with me right now, and we're going to review that method we already know, and then from that, we're going to learn about a new method that they might not have seen before. So, boys and girls, if you would, let's go ahead and try to work this problem out together. Let's say we have a divisor of 23, and let's say we have a dividend of 5,313. Go ahead and use the standard algorithm that we have used in the past, the one that I've taught you earlier in the year, or reviewed with you earlier in the year. Go ahead and work this one out the way you usually do. I'll give you a few minutes head start, and then I'll work it out as well. So go ahead and work on that. I'm just walking around the room, watching as students are working these out. I notice that the students are using just regular lined paper, the same type of paper that I'm using in this demonstration. When we first started doing long division, we actually used graph paper. We liked the way that the little unit grids helped us keep track of our place values, and everything worked out nice and neat. And I see some of my students are already working on the problem and have just about got it figured out. Now, I'm going to go ahead and join in on solving this problem. When I look at 23, I know it's obvious that 23 is not going to be a divisor of 5, but it will be a divisor for 53. So I can say 53 divided by 23. I can get two groups out of that, two groups of 23. So 23 times 2, or two groups of 23, is going to be 46. Now I'll subtract that, do a little bit of regrouping here. 13 take away 6 here will give me 7, and then this one, I'm going to bring it down. So just to review the steps I've done so far is I divided, then I multiplied, then I subtracted, and then I brought down the next digit. So I have 71 here. Now if I had 25, I know that 3 25s will equal 75. I think that 3 23s will be close to 21 without going over. So I'm going to go ahead and put a 3 here. I think I can get 3 groups of 23 out of this 71. So I'll go ahead and now multiply again. I'll subtract again. And then I'll bring this 3 down. And I got 23, one group of 23 and 23. And I'll go ahead and finish it on out. So we got the quotient of 231. How many of you got the quotient 231? Just show me a good show of hands how many got that part correct. Okay, I'm looking around the room and I see that most students got that correct. So you can put your hands back down, please. Now there's another way to work that out. Let's say that you had difficulty using the standard algorithm that we have already learned, and let's look at another way to solve this. So what I'm going to show you may seem pretty radical, but watch what I'm doing. I'm not even going to ask you to imitate it or anything right now. Just watch what I'm doing, and then we'll talk about it. I'm going to put 23. I'm going to put 23 right here. And that 5 that's left alone, I'm going to put it here and make a problem like that. Then I'm going to say 23 again, and then this 3 here, I'm going to put it here, but I'm going to leave space. I left a little bit of space there. And then I'm going to go ahead and say 23 here, and I'm going to leave a little bit of space, and I'm going to put that 1 right here. And I'm about to run out of room, but I think I can do it. I'll put 23 here, and then I'll put a 3 here. And I'll leave it like that for just a moment. Now, one of the things that I'll point out to my students is you'll notice that I took every digit in that number, in that dividend, 5,313, I took every digit in that number, and I gave it its own division symbol, we'll call it. I gave it its own little den, if we want to talk about the dividend being in a den. Just as a show of hands, how many of you have seen this before, children? Raise your hands if you've seen this before. I want to know if this is something brand new. I'm looking around the room. I'm seeing one child with her hand kind of up. Now, you came to us last year from another district. Was this a technique that they showed you in the 5th grade last year in the other school district you went to?
My teacher showed it to me once, but I didn't really understand it, so he just told me to do long division if it made it easier for me.
Okay, I like what she just said. She said, do whatever it is easier for you. If the standard algorithm that you did just a moment ago, and I saw a lot of hands go up, if that's the easiest way for you, it's the way you're used to, if that works for you, then use it. Then use it. All that we care about is, do you get the correct answer? And do you have a procedure or strategy to get that correct answer? Those of you who were unable to use the standard algorithm that we've traditionally used, maybe this technique I'm going to show you will work better for you. And if it does, then use it. Okay, so this is just another technique that we use. There's also one technique, if you go on to my YouTube channel, I found a video where this one math teacher was doing a chunking method. I'm not going to do chunking method. I think that's too many methods too soon together. But you can go on my YouTube channel and find where I clicked on, added to my favorite playlist, that chunking method, and you can see that technique. But let's go ahead and see how I solve this one. Now, I'm going to do like a teacher model. This is a teacher model. You just watch what I do. It's like a teacher think aloud. So the first thing I'm going to say is that I can get 0 groups of 23 out of 5. It's just not going to happen. When I was over here, I did not even put a 0 here. I just went straight to 53, and so I could get 2 groups out of it. But now here's what I'm going to do now. I take this 5, and it's going to travel. It's going to travel in front of this 3, and I'm putting the 5 right there. And I can get 2 groups of 23 out of 53. So 23 times 2 is going to give me 46. I subtract 46 from 53. And if I do a little bit of regrouping here, I get 7. Now, ordinarily we would refer to this as a remainder. But I still have more digits in my number. So this remainder here is going to travel up to here, and this becomes 71. I can get out of 71 3 groups of 23. So 71 take away 69. That's going to give me 2. This 2, which remains, is going to travel over here. 23, I can get 1 group of 23 out of 23. Now, I have 0 remaining, but watch what I do now. This 0 is like when we have decimals and we have leading zeros. It has no value, so I'm not even going to write it down. I'm just going to go ahead and write these digits down in the order that I have them. So 2, 3, 1, and it makes a quotient of 231. So I had 231 here when I did the long division way, and I have 231 here. Now, some of the things that you'll see they share in common. When I had 5 here, I didn't get any groups, and I didn't get any groups here. Then, when I went to 53, I got 2 groups of 23 and got 46 here. And here, I took that 5, put it here, and I had 53, and I got 2 groups of 23 and gave me 46. And I have my remainder of 7 here. And then I bring the 7 here, and I got 71. Well, here where I had 71 remain and brought the 1 down, I also got 71. I have 3 groups of 23 here, which gave me 69 and remainder of 2. Once again, 3 groups of 23 gave me 69. I had 2 left over and brought this 3 down for 23. This 2 traveled over here and gave me 23. And I was able to get 1 group of 23 out of that 23. And so I got a quotient of 231. So those are 2 ways that you can complete long division problems. Now, let me just see a show of hands, confidence level. How many of you think you can do this new method I showed you? I almost want to call it expanded form, but I don't know if that'd be appropriate or not. I see just about everybody in the class is wanting to try this out, except for about 3 kids whose hands didn't go up. All right, let's go ahead and we'll work on another problem. On this problem, I'll let you work on it with your elbow partner. You and your elbow partner can work on it together. When you get it done, I want you to compare the quotient that you got with your whole team. So, let's see a good problem I can give you. Now, I'm going to write this problem just like I did this one, but you will need to expand it like we did here. So, I'm going to pull this up here. Well, I'll tell you what, just to make sure you can see this as a model, I'm going to leave this here. I hope I'm not making you dizzy, moving this around so much. And I'm going to put the new division problem right here. I'm going to put it right here. So the new division problem, let's say that I've got 13 as my divisor, and my dividend's going to be 2,899. Now, this is the problem that I want my students to work on. Now, I'm going to leave it to you. If you want to do it the standard algorithm way that we've practiced in the past, you may. If you want to expand it out, like we did here, you can do that as well. Remember, it's like what Balin said a moment ago that her teacher told her. What's easy for you, what's comfortable for you is what I want you to do, but you're going to have to master one of these methods. You have to master it. All right, I'm going to go ahead and give you about 5 minutes on this one, and then we'll see how you did. Okay, we've allowed a few minutes to pass so that elbow partners could work on the problem and then as a team see if they can solve it. I have some really interesting results. I got one little feller. I'm going to let him come up with his paper first, and he'll talk to us about his experience trying this new method. I'll go ahead and move my paper out of the way so he can put his paper in its place. Now, if you would, talk to us about what we're looking at and how you feel like it's easier, more difficult. Did it help you understand anything better? What would happen?
Okay, it helped me understand better because what I did is I got the numbers and put them in groups like 13 and 2, and then 13 and 8, and then 13 and 9, and then 13 and 9 again. And then what I did was I took 13 into 2, and it wouldn't go into 2, so I put a 0 on top, and then I brung the 2 over to the 13 and 8, and then I got 28, and then I times 13 times 2, and then I got 26, and then I got 2, and then I brung it over to the 13 and 9, and then I times 13 times 2, and then I got 26, and then I got 3, and then then I went back over to 13 and 9, and then I brung my 3 over to 13 and 9, and I got 39, and then times 13 times 3 and got 39, and then I subtracted them and got 0, and the complete answer I left out the 0, and I got 2, 2, 3, and that was my complete answer.
Okay, so you got 223. Let's look around the room. How many other people got 223 as the answer? So, Logan, you were able to use this method, and you said that this method was easier to you than the traditional standard algorithm we've been using?
Yes.
And you think that this is a method that if you had more practice on it, this is one that you could master?
Yes.
And so you think that this will help you if we were like in a K-prep situation and you're on the part where you can't use a calculator and you have to do long division like this, you're going to be able to use this form that we're doing today, this strategy we're doing today, and it'll help you.
Yes.
Okay, so I'm really glad that this was helpful for you. It was successful for you, but let's talk to somebody who decided to use the old standard algorithm and see how they did. Let's get little Ethan up here. Okay, so Ethan, it was interesting watching him and his partner work. His partner did the expanded type form that we just learned, and Ethan, he did it the long way. Now, Ethan, why did you choose to do it this method?
I think it's easier to line your things up.
And
And
this
your
was one way that you already learned and mastered, and so you just want to stick with tried and true.
Yeah.
Okay, talk us through what you did here.
First, I multiplied 13 times 2 and got 26, subtracted it by 28. I, I got 2, brought down my 9, then 13 times 2 again, got 26, subtract that, got 3, brought down my 9, and I knew that 13 times 3 is 39, then I subtracted it and got 0.
Okay, so that's really good that you were able to use your old method and it worked for you. One thing I do want to point out to my students with this is I noticed that our remainder was 0 this time, and with our first problem that we did, we also had a remainder of 0. If it turns out that you have a remainder, we've already talked about the 3 types of remainders that we can have, such as the fraction, the decimal, or the R remainder. What I'd like for us to use from now on, just as our standard, this is going to be the standard that we're going to use from now on, we're going to do the fraction, because I think that better shows, and since we are going to be doing fractions this cycle, I think it better shows how much is really left, how much of the divisor is actually left from the dividend when we show it as a fraction. All right, we'll do a few more practice items, and then we'll do a little Mastery Connect assessment to see if you've mastered long division.